Hello, everyone. Thanks for joining this live stream. I'm Christian from the blockchain team. Welcome. So, what I'm going to show today is um, what's new in our functions. Note that all these functions are experimental, and that means that they may change in the future. And but I want to show you what we have right now and do a walkthrough of what we have here. That are some cool examples um, we wrote for version 12. So before going um, to the examples, I wanted to make us a overview of what kind of functions we have. And actually, if you go to the documentation here, this is something that we are also going to update. You'll get a sense of all the things we can do with blockchain stuff. But I'll show the main things I want to cover. So we have a whole set of blockchain functionalities. Some of them are used to read data from blockchains. So the first function we have for that is blockchain data. So blockchain data returns basic information about the blockchain, about the status of the network. Um, so in this case, we default to Bitcoin, and currently we are supporting Bitcoin, Ethereum, and Arc, both their mainnets and testnets. So we can actually try something like this. So we have the blockchain-based option that is it's the option that you can use to select the blockchain you want to work with. So if we do something like Bitcoin and Bitcoin testnet, we also have Ethereum testnet, and this should work also with Arc. So in the case of Arc, and that also depends on the blockchain. So it's not called testnet, but it's called devnet. So let's try to run this using a dataset like this. Just to show you the different properties these blockchains have. Um, yeah. All right. So as you can see here, these are some details about the um, Bitcoin mainnet, the testnet. Same thing for Ethereum. We have this for Arc and Arc DevNet. So you can see different properties for Arc. Like in this case, we are also showing the token and symbol. Um, it's cool that their symbol is called dark in their DevNet. All right, so that's the idea of blockchain data. So it's just some general information about about the network. So we also have the blockchain block data function. So this function returns information about a specific block. So in this case, for example, if we try with a Bitcoin blockchain, and this -1 means that we are going to get the latest um, mine block. We can also try some specific block like this one. And so as I mentioned before, these are experimental functions, and we're currently adding more data to it. Like if you go to the documentation page here of blockchain data, you'll see some properties here. Those same properties are here, but we are also adding more like these amounts property where we are adding information about the amounts in this particular block because we think this is useful information and it's computed information we have um, to avoid people to check all the transactions and compute this. All right, so with this, you can read um, blocks from all the supported blockchains. So if we try something like ARC, let's try the latest block here. All right, and again, it depends on the blockchain. So in this case, you see that ARC has some different properties. All right, so we're talking about blocks, and now we can talk about transactions, and that's the blockchain transaction data function. So with this, and let's use, I don't know, let's use something like this. Um, so let's extract the transactions of this block. So let's do transaction base here. So with this, basically, I'm going to extract the transactions included in this block. So let's do a random choice of this. Let's call this transaction ID. This is just one random transaction. It can be any transaction. So I now can get information about that transaction using blockchain transaction data. In this case, from the Bitcoin blockchain, but the same should work for all blockchains. So as you can see here, you get the summary of properties of this transaction. I like a lot the Bitcoin one because we provide the input and output scripts, as you can see here, and we are actually working on also making these scripts computable in Wolfram language. All right, so those are the main functions to read data from the blockchain. There are some more functions to read information from tokens and contracts. We'll see that in the examples, but at least for you to have a sense of what information you can get from the blockchains, I wanted to start with these three functions. And we also have a family of functions to write data to blockchains. And the main function or the main symbol for this is it's a blockchain transaction object. So if you see here in the documentation, we have, this is a representation of a transaction like here. This is a representation of a Bitcoin transaction. And we can, I'll also going to show more of these in examples. But basically, when you have this represents a transaction. This is still not, in the case of Bitcoin, this is not a transaction that has been signed yet. So for that, we have the blockchain transaction sign function. So with this, you provide a private key, and you can sign a transaction with that. So actually, let's try with this private key here. So if I have this transaction, I think is the same one as here. This is testnet, so that's why it's fine just to share this private key because it's not real money. So if we try this, yeah, it's signed. So you see the property changes from false to true. But again, this is just a representation of the signed transaction. If you actually want to submit this transaction to to the blockchain, you need to use the blockchain transaction submit function. So once you have a signed transaction or whatever the blockchain requires you to have a complete and well-defined transaction and it's ready to be added to the blockchain, you can use this. I'm not going to um, run this. I'm not going to submit this transaction because it has been submitted already. I will need to create a new transaction, but we can do that later. But the idea is that we blockchain transaction submit, as you can see, also the properties change a little bit. You get a transaction ID. The colors change here to indicate that the transaction has been submitted to the blockchain. And now you can query that transaction using transaction data or using a block explorer. All right, so let's see the examples we have here. So we have this page where we select some cool examples that represent interesting things you can do with our functions. So I want to review basically all or most of them and try to expand the concept if it's necessary or if you have questions. All right, so this example here is not related directly to a blockchain, but is we added it here because it's useful when dealing with cryptocurrencies. So we have a currency convert function that can convert between regular currencies, like let's say $10. We'll convert these to euros. And so if I run this here, I should get the actual value of $10 in euros. Well, this runs. Yeah, so it's here. So the same thing can work with. So I'm using this cloud evaluate instead of just running this because yeah, I'm currently just experiencing a problem with this, but we have the cloud to save the day. So this works fine in our cloud. So I'm basically asking the cloud to run this for me and to get the output. So right, so it works with regular currencies, and if we do something like 10 bitcoins and use something like, let's say, Peruvian soles, um, I should also get the result. And we also support um, other cryptocurrencies. Like you can uh, compare between, let's say, Bitcoin and Ripples and other currencies. So the idea of this example is it just to use this function to create a form page where you can play with these conversions. So for this, I'm just defining what I'm going to submit to the cloud. So if you see here, what I'm using is an interpreter. So I can. So this allows me to use natural language in a form page I'm going to use um, to parse the amount and to parse the name of the currency. So if you see here, I'm testing the the converter. So I'm saying in words 10 bitcoins and convert this to US dollars. And they should understand, uh, sorry, they should understand that I'm referring to bitcoins and to dollars and parse this correctly, like here. All right, so once we have that, I just make a simple form page. So the actually the only thing you need for the form page is this. Um, I'm just adding more uh, fancy stuff to add a title and description. And so let's try. All right. So if I do a cloud deploy of this form page, let's put the permissions on as public. Yeah. So I have my converter here, and you can play with the design if you want something different. Like I'm not sure what themes we have. Um, I don't know. Let's try with red just to show a different theme from the examples we have in the page. And the cool thing is that these form pages also work on mobile. So, oops. Um, yeah, okay. So I personally use this a lot. Like I have this kind of form pages to do some computations, and I use my cell phone to run this. All right, so let's try something like 100 ether to euros. So I'm also going to share, yeah, so this is the result. And if you want to try this on your cell phone, you can, if you have a QR code scanner in your cell phone, you can scan this code and you'll get the website in the mobile version. So you can also test that here. All right. So yeah, this is just a basic example showing how we can handle cryptocurrencies and compare between them. All right. This one is a simple example, but I think is a very powerful feature of the language. So what we are doing here is creating a blockchain API. And And for this, I'm going to use the API function, which I think is a super powerful function to expose everything we have here in the language to other languages and other systems. All right. So in this case, what I'm going to do is it's just a uh, again, it's just a very simple example. So I'm showing here how you can, and I already showed that before, that you can get information about a block. So let's say going to let's get the byte count. That's the size of the block. So in this case, I'm using Ethereum, but to show you that this can work with other blockchains, let's try with Bitcoin. So now we want to make a general function to get um, the byte count from any block. So if I do something like block here, and let's call this, I don't know, block size, where I have to provide a block. currently I'm going to just use the Bitcoin blockchain. All right, so let's try something here. If I do this, I get the result. Okay, so this is fine. This is working um, in Wolfram language, but what about if I want this to work from other language or other system? So I have this API function where I'm defining one parameter that is the block, and I'm creating the result that is just a string concatenating uh, the output of this. And I can actually use the function I just created here. So it's block size, and it will return, it will need the block. I need to do this. Yeah. All right. Okay, so if this works correctly, I'm going to deploy this to the cloud. I'm going to set the permissions of public because I want to test this from other languages. So if I go here, it will probably ask me for the parameters. So yeah, it's saying that it needs the block parameter, which I didn't provide. So I'm going to do something. So if I go to my terminal here, and I'm going to use this API I created, I'm going to curl the API. And the parameter I need is the block. So let's try this. Yeah, so I get the result here. So 216 bytes. And, and that's the same thing I should get if I go to this. So that was block 50,000. Yeah. So here, as you can see, I'm not using Wolfram language anymore. I'm using a Bash terminal. I can go to Python or any other language that supports, and that supports HTTP requests, which basically most languages support that. And now you're exposing all these powerful blockchain functions to any other language through a RESTful API. Okay. All right. So this is a fun example because it comes from something I did some time ago. So we wanted to encode data in the Bitcoin blockchain, and as you know, the Bitcoin blockchain is not designed to uh, just store random data. So there are I've seen like maybe 5 or 6 different ways and proposals to save information in the Bitcoin blockchain, and I think I came up with my own version of this. It has some limitations, but it also um, has some positive sides. All right, so this is where we're gonna read encoded data from the Bitcoin blockchain. Okay, so remember I was showing you before that we have the blockchain base option. So if you want to set this set the default value for this option, you can use the dollar blockchain base variable, and we'll set this to Bitcoin testnet because I encoded this data there. So if since I now have this set to the testnet, if I do something like blockchain data, this should return As you can see, the information about the testnet without me specifying the blockchain base with the blockchain base option. All right, so I have this transaction ID. It's here because this is where I encoded the data. Um, sorry. All right, so what's happening here? So what I'm doing is with blockchain transaction data, um, I'm extracting the outputs of this transaction, just the outputs, because this is where I encoded the data I wanted to store in the Bitcoin blockchain. So as you can see, there are many outputs. Let's see how many, like 16, 17 outputs. All right, and from here, I'm going to extract just the amount, because if you see this, there are, so here you can see the script, um, you can see the address associated to this transaction, to this output, but I just want to get the amounts. So that's what I need to run a lookup, and then basically saying, so extract just the amount property or the amount field from this association. All right, so you have here all the amounts in this transaction, and finally I run this just to get this amount, because the first amount is the change I sent back to myself when I created this transaction and I submitted um, all this information to the blockchain. So I'm just keeping these outputs, these amounts of these outputs. All right. So yeah, maybe you don't notice something very particular about these amounts, but they do have something in particular. So basically what I did here is I encoded the the data I wanted to store in the Bitcoin blockchain in these amounts. And with this code, I'm going to save these two amounts. Um, what I'm doing is I'm getting the binary representation uh, of these amounts, and you'll see why I want to do that. And with this code, I'm just making adding the appropriate data to have this in a particular form that is a cellular automaton. So basically, what I'm doing here is adding zeros until I have the full length, which is probably this one. So if I do something like array plot of this, oops, what I'm missing here. Yeah, I think I'm missing something. Anyway, um, yeah, so it's this last step of the CA, which is rule 110, I think. Yeah, actually, you can compare this to this one and see that it's the same. And to prove that, if I do output 49 and compare this to output 52, yeah, I should get true. So the idea is that in the outputs of this transaction, I encoded cellular automaton. And with these reading functions, we are extracting and doing some magic to put it in the appropriate shape, and you get the CA here. And also, so it's not included in example, but how I encoded all this data and how I submitted into the Bitcoin blockchain. I also did that with the writing functions we have here in the language. Um, all right. So I mentioned before that we also have um, other functions to read information from the blockchain, not only the ones I showed. This is one that we are still expanding to get address data from different blockchains. So, but in this case, basically what is happening is that I'm querying the Ethereum blockchain for this address. So this is returning, I'm asking for the transaction list. So basically these are all the transactions associated to this Ethereum address. And in this example, I'm just showing some stuff you can do um, with the data we have here. So basically what I'm doing is I'm splitting the data in two. So in this variable, I'm saving all the transactions where this address sent Ether to someone. And here are the transactions where this address received money. And yeah, and now I'm just want to plot. So I'm just extracting from this variable. You want to see what's here, you can see that you have a lot of information. I don't care about all the information. I just want the time and amount to make a date list plot and compare the transactions, the amounts sent and the amounts received over time. And this function, the blockchain address data, also works with, let's try with Arc blockchain. And in the case of the Arc blockchain, they not only work with like text strings for the addresses, you can also put your addresses with a username. So let me put this as a data set. Okay. Yeah, so you can see here some information about the this Arc address. And again, it has different properties because it's a different blockchain, has different structure. All right, let's continue with the. I'm gonna leave this for later because this query may take some time. Uh, I'm just going to explain real quick that what we are doing here is extracting the last 100 blocks from the Bitcoin blockchain and compute the time between those mined blocks to get an average of the mining time that should be around 10 minutes. So I'll leave this for later because it can take a while to run this. Okay, this is just another example on how to use the data from the blockchain to do something interesting. So in this case, we're making a visual representation relative block size. Visual representation of the size of the block. So we already saw this before. You can get the byte count, which is the number of bytes, the size of the block. In this case, I'm using the Ethereum network and the mainnet and the testnet. So I'm using the last block from mainnet and from testnet. This is about a bit more than double the size. And this is just a fancy code to create this visual representation of the sizes. So here in red, you can see the size of the testnet block, and the black box is the mainnet. So it's helpful to, at least for me, it gives me a better idea of how big or small are the blocks, if you compare the mainnet to the testnet. Let's do a quick test here. Let's try with Bitcoin. Maybe this is too big. Well, yeah, you see the difference here. So in this case, the Bitcoin testnet is much smaller than the mainnet. All right. Well, this is a fun example of something cool you can do with our functions. I call this Bitcoin music. So basically what I'm doing here is I'm extracting the transactions of one particular block. So in this case, you see all the transactions included in this block. And then what I'm doing is I'm getting the ASCII code of every transaction, and just playing a little bit with the values. I get um, the range I need. I'm only using 100 transactions because I'm going to create a sound out of this, and I don't want to uh, have a sound of playing for 1 hour. So this is probably going to be just some seconds. So if I map all these values to sound nodes, I choose one instrument here. You'll see that we have a lot of instruments here. So with this, I'm going to get uh, a sound made from transactions, basically. I don't know if you can hear this. Um, so actually, let's do something. Um, I'm going to deploy these to the cloud, so you can test this from your cell phone or from your computer. All right, so let's call this Bitcoin sound. This is going to ask for a block number, right? And with this, what else do we need? Okay, so let's copy all this here. The values are this. And what else do we need? I need this function here to extract the transactions. And that will be block. Yeah, like this. What else? Yeah, I think it should work. And this thing is updating um, the sound note instrument. So should I'll just cancel this and let's try these functions. If I provide something like this, yeah. All right, so let's do something. Let's create a form page. I'll ask for a block. This is going to be a integer, and the block will be used here. And I think this is everything we need. So I'm going to cloud deploy this set the permissions as public. All right, so let's try something like this. And this should produce um, a sound file. And for this loads, let me create QR code of this website. So let's see. Yeah, it's here. Probably I have to query for um, another block with more information. So actually, let me try this from my cell phone. So you can see my cell phone, but I'm going to scan this QR code here. And I can now see the form page. So what I want to try here is um, the form page so you can listen to what this produces. Let's try. Okay, while it's still loading. But you can also go to this. Okay, it's now here. All right, so those weird sounds are coming from my cell phone using the form page I just created and using one block from the Bitcoin blockchain. So I encourage you to go to this form page. You can just scan this QR code from your cell phone and try that crazy music you can generate um, with these functions. All right. This is another example that uses a very similar query that, like the one I was mentioning before, is going to take a while. So I'm leaving this for later if we have enough time. But basically, again, I'm extracting the last 100 Bitcoin blocks and running some statistical analysis um, of all that data. Um, all right, this is practical use case of our function. So in this case, the function I'm going to use is it's not a blockchain function, but it's a cryptography function. So let's call this create and share a blockchain address. So I have uh, the function generate a symmetric key pair. If you go to the documentation, you will see more details about this and the things we support. In this case, what we want is to create a pair of keys using elliptic curves. And so you can use something like elliptic curve here or Bitcoin to use the Bitcoin elliptic curve, which is the same one used by Ethereum. Okay, so I have now a set of two keys. So I have my private key and my public key. And with these, so you may know that the address is a type of encoding of the public key. So if I do something like public key and use a blockchain key encode function, I'm going to get the address. So in this case, this is the address produced by this public key. And I think this is a Bitcoin testnet address. And this is because we were using this, right? So you also had the blockchain-based option here. So if you use the Bitcoin blockchain base, you will see that it has the mainnet structure. You see the one here for Bitcoin testnet. You have the again, you have the structure. But I want to try something here. I'm going to create an Ethereum testnet address. This one. Um, so let's see what happens if we run this here. And let's use. So this address still has nothing, so it returns missing. So let's see if this works. All right, so let's go to Ethereum testnet faucet. Oops, to get some ether. All right, so this page is going to give you ether on testnet. So I need to copy this here, and I believe you need to add this. Okay, so I just send ether to this to the address I just created. This is still pending. We'll probably need, I don't know, some more seconds for this to be mined. Okay, let's continue um, checking the example while this is mined. So basically, the idea is that once you have an address, like in this case, it's easy to share it. So one thing I like to do is um, use a QR code to uh, to 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 share my address. So I can do now something like send message to send this to my cell phone. So I'm gonna use the MMS channel and say something like my Ethereum address and then oops, this thing here. So this should work, I believe. So by sending this to my cell phone, I have now um, the QR code. Yeah, it's here, and well, you can't see my cell phone, but I may be able to open this here. So I just got a message saying that I received a message from this number, and the QR code is here, and I can visualize the same thing for my cell phone. All right, so let's see what happened with the transaction. Well, it seems that the block hasn't been mined yet. Let's try something like blockchain transaction data of the transaction that has the ether I sent to this address. Blockchain base, this is Ethereum testnet. Yeah, so it's still pending. So we can go back to this in a while once this has been mined. Yeah, let's just wait. So basically, the idea again is that with this cryptography function, you can create a pair of keys. In this case, I'm using the public key. You can also use a private key if you want to submit, if you want to sign a transaction like I showed before. Um, and encode the keys as an address, or we support other things like the WIF format used in Bitcoin. And we'll eventually add more stuff to this. Let's try one more time here. Well, at least you can see that a real transaction was made. We're just waiting for it to be to be mined, and it was sent to the address I created here. Okay, so this one here is another function. Again, is an experimental function, and we are also trying to always expand and get more useful data. So basically, what I'm doing here is, where's my notebook? Is extract information about Ethereum tokens. So if you check the blockchain token data documentation, you'll see all the stuff you can do with this. Currently, what I'm doing is saying, okay, give me the name of all the tokens, and I want two properties out of them. I want the name and the transfer count. So if I run this here, oops, I need to change these to. So this is good that this happens because it tells us that our errors are working. Of course, Bitcoin doesn't support tokens, and this is um, telling us that we have an error here. So I have to set this to Ethereum. And if I make a word cloud, so I'm asking for the name and the transfers count to give a weight to each token, so I can do something like this and see what tokens have um, the largest amount of transfer counts. And probably if we compare these to the results in the example, yeah, so when we released version 12, CryptoKitties was uh, the main token here. Now we can see that this is not the case, and this is real-time data. So um, it's cool that we can see the difference between the time. Just let's see this. Okay, so this has been mine. Just not to lose what I wanted to do before. Before we continue with the tokens, I just wanted to show you that this transaction has been mined. So we can see now the information here. And with the address I generated before, let's try something. Yeah. So as you can see, I now have this amount of weight. That is the amount the faucet sent me. So it sent me 1 Ether. So yeah, it's here. So it's working. That's pretty cool. All right. So this example is just to show you that we can get information about tokens. And all right, so this one here is a example where we use blockchain transactions and we actually submit that to the blockchain. And so I'm going to explain um, this example, but I'm also going to use this thing we created before, the address and the money we send to this address. So you have a better idea of what's happening here. So this is called blockchain game. Okay. So what we do here is we create a blockchain transaction it's just a representation of transaction in testnet. And basically, so we have the sign. I don't have the private key here right now, but the idea is that we have the signed transaction, as you can see here, and as I showed before. And So I'm not going to run this, but what this is doing is I'm creating a scheduled task that it will run every hour. And this scheduled task is going to do a weather data query. So it's asking here, asking for the temperature in Lima, Peru. It's asking if the temperature is higher than 33 Celsius. What you're going to do is you're going to submit this transaction. And this transaction is doing something. It's sending this amount of Bitcoins to this address, basically. So you're just gambling that the temperature is going to be higher than this. And if it's true, you're going to get money. So it's a simple example of a transaction. So since I'm not going to run this because I don't have the private key, what I want to show is how I can make a blockchain transaction. So let's go back to this example here. So we created this address, and remember we sent um, some money from the faucet. So let's say something like creating a transaction. So we have the address, we have the money, and we have the keys. All right. Um, so something I do, I don't memorize the whole structure of the blockchain transaction. I just go to the documentation page and use this. Okay, so in this case, my address is, I'm going to create a new address. So it's called new keys, generate a symmetry keeper, the Ethereum curve, and blockchain key and code of this public key. And I want to encode this as an address. An address. Okay. So I'm going to send this amount of ether to this new address that is also controlled by me. Oh, let's just use the one. Yeah, let's just use the one I have from before. All right, so for this I have to sign the transaction, blockchain transaction sign, and I'm going to use the private key here. So this should sign transaction. Yeah, it's signed. And now I'm going to blockchain transaction submit. I'm going to submit this transaction to the blockchain, and if I get the transaction ID, it's here. So I think we have just like 1 minute left, and we'll check this transaction. Just before that, I'm just going to explain real quick um, this example here. So this one, this comes from some websites I saw where they investigate the CryptoKitties genetic information, if we can call it that. Um, so this is going to use Ethereum. So what I'm doing here is I'm using the blockchain contract value Uh, we're still improving this function, but basically you are querying the smart contract associated to the CryptoKitties, and should just change the color blockchain base. And I'm getting the properties of one specific kitty, like in this case, this one. And with this code here, uh, this is just code to get all that information from the smart contract. So it's actually already here, and what I'm going to do it just real quick. I'm extracting the genes and the ID of the CryptoKitty mom and the CryptoKitty dad, and and again querying the smart contract to extract the genes from the mom and the dad, and I have this function to create what is called the kind notation, that is something used um, with this CryptoKitties data. And again, this is just code to make this look pretty. So basically what I'm doing is getting the genes from the CryptoKitties, assigning colors to them, as you can see here, and finally making some kind of genetic plot where you can investigate the inheritance of genes. So you have the mom, the dad, and the CryptoKitty, and some different features of the kitties, and everything. All this data came from the Wolfram language. So it's just an example to show you uh, how you can query smart contracts. So I think this is a good overview of everything we can do. Um, and yeah, we hope to get your feedback and suggestions and questions. And I know that we are always working on improving this, and these functions will be kept experimental for some time, and we'll keep adding more blockchains. And yes, I think that's everything for now. I hope you like it. Thank you very much.